So now we have a very different problem. Well, it looks different because it's long, but it's not hard at all. Okay, so we have a centrifuge that spins at a given rate. Okay, so first thing you need to know, whenever you look like something over a minute, that is not a velocity, that is a frequency. Okay, so that means we got this, a frequency. And from there we know we can get a period. Okay, so that's the first thing we need to do. Okay, so well, first of all, we know that frequency is in revolutions per minute, so we will need to change it to revolutions per second. How to change it? That would be 15,000, sorry, revolutions over minute, and let's change it to revolutions per second. So we know that 1 minute is 60 seconds, and that would be, let me write it down here, 250 revolutions per second. Okay, so pretty much there we are. So from there we know that we use this other formula for new things. Okay, we need to know the centrifugal acceleration of the test tube. Now, how to know that? Well, we first need to compute the velocity with those formulas. That is like 2 pi r over over the period, or that's exactly the same as writing 2 pi r times the frequency. And from there we start, and that would be like 2. It's a 2. Pi, it's a pi. Radius is 15 centimeters, but I'm gonna write just like 0.15 to get all in meters. And I had 250, and that is gonna be, if my computations are right, are gonna be 235.61 meters over second. Okay, so we have the velocity there. From there, we can actually compute the centripetal acceleration, and that's gonna be here. That's that velocity squared over the radius. Yep, pretty much. So this is gonna be 235, well, 35.61 squared over 0.15, and that's gonna be a very odd number. That's third, well, weird number. 7,010. Yep, there we go. And that's meters over second squared. Okay, so there we go. We know this information for sure, and this is just part A. Let me write it over here. Now we're missing part B. That's gonna be as easy as hell. So let's start with this. I'm gonna use an orange now. Here. We know the total time. It's 65 seconds because it's 1 minute 60 seconds plus 15. That's 75. Sorry, my bad. I need someone to correct me right here. Hey, some of you, that would be nice. There, 75 seconds, and we know that the final speed, yep, it starts from rest, so the initial velocity is 0, and the final velocity, it's the one we computed here. That's 235.61, and that's meters over second. This guy over here is 2 meters over second. So how do we compute it? The same way we have done it all the time, and that's gonna be the tangential acceleration is gonna be the final velocity minus the initial one over the final time minus initial time. That's gonna be 235.61 minus 0 over 75 minus 0, and that if my calculations are okay, that's going to be 3.14 meters over second squared. Okay, so that's pretty much this problem.